Hey everyone, thank you so much for watching another Weaviate release podcast, releasing Weaviate 1.19. We have all sorts of exciting new features, but before diving into any of the features, Etienne has on what I think is the best iteration of the Weaviate shirt. So Etienne, thank you so much for joining the 1.19 podcast.
Thanks for having me. I'm calling this the 1.19 shirt. I think it's not the the 19th iteration yet, but it fits perfectly with all the cool stuff that we have in the new release.
Yeah, awesome. I remember we had joked about having like a t-shirt for all the blog posts, the blog cards as Philana makes, and I really like the look of it. So super cool. So let's kick it off with the gRPC API and the story around what led to that.
Yeah, gRPC API was sort of an initially unplanned feature, but we wanted to add a VBA to ANN benchmarks. And in ANN benchmarks, we've talked in the past, we've talked about the sort of library versus database split. And in ANN benchmarks, you have all these libraries. And but now also a couple of databases. So we thought like, okay, yeah, we have nothing to hide. Let's get VBA in there as well. And what you can see in those benchmarks is that especially for the so for those of you who don't have the context in the benchmark, essentially you have a graph that on one axis shows you the recall and on the other the latency. And with any ANN algorithm, especially with HNSW, with any, it's always a trade-off between recall and latency, or throughput as sort of as the inverse latency, basically. So throughput in the ANN benchmarks is actually estimated because it's not really a throughput benchmark. It really just does single-threaded individual queries. And then if a query takes, let's say, 100 milliseconds, then the throughput would be considered 10 per second. So just 1 second divided by the individual latency. The actual latencies are way lower than 100 milliseconds. But that's kind of the benchmark setup. And what you can see in those sort of low recall settings, of course, the latencies go down quite a bit. But that also means that everything that you have as constant overhead, so let's say a vector search takes, for example, half a millisecond, but you have a constant overhead of half a millisecond, then all of a sudden in these low recall situations, you now have 50% overhead, or depending on how you see it, 100% overhead. And that's not great in benchmarks. So we thought, well, what can we do here? And can we do something that doesn't just optimize for benchmarks? Because that's kind of, well, I don't want to say it's pointless, because in the end, benchmarks are a great signal for users and they help them sort of decide. But also, to some degree, if you over optimize for benchmarks, you always have to ask yourself, like, what benefit does the actual end user have? And we looked at the gRPC API and adding gRPC API sort of in the background for some of the clients. So what is super important for us was to make sure that there are no breaking changes, or that users would have to sort of start changing their usage patterns or would have to learn something new. No, we've sort of slowly started adding this gRPC API, which some endpoints, not all yet, but some can run with this. And the Python client, for example, can automatically discover if gRPC is enabled. It's also an optional package on the client side. So if you don't have gRPC installed, then you don't have to install it if you don't like it. But if it's there, it's used in the background, and that allows you to basically have more efficient queries, where just the overhead and of course that overhead before it, I think it was around 500 to 600 microseconds, so it's a bit more than half a millisecond. That was there in every request, but the shorter the request duration is, the more noticeable is the overhead. You could argue that a user would never notice in real life, and that you only argue it in that you would only notice it in benchmarks. But nevertheless, overhead is there and overhead is gone. So making something more efficient is never a bad idea, I think, even if you could argue that most users might not see the real life impact.
Yeah, and so I definitely want to dive a little. I have a couple more questions about how these ANN benchmarks and the recall latency, but maybe just super quickly. So gRPC, GraphQL, HTTP. Could you just quickly give me the difference?
Yeah, so interestingly, gRPC actually isn't a separate protocol. It runs over HTTP too. So from a sort of these are all sort of one layer higher than the TCP stack. They all run over TCP, and then gRPC basically runs via HTTP. So the way, and this is a very interesting, because I think some people just assume that gRPC is faster because it's a faster protocol, but it's actually not a faster protocol because it's the same protocol as HTTP. And by the way, GraphQL is also typically sent over HTTP. It's simply that uh, gRPC uses the protobuf protocol, which is very, very close to how the data types are represented in their respective languages. So the Go memory model is very similar, basically, to the protobuf structure, and then also the memory model in Python. So if you have this sort of network request Go, which is Weaviate, the Weaviate server, via gRPC to Python, there's simply way less sort of decoding, encoding, restructuring, not restructuring, but sort of re-encoding that you need to do. Whereas both GraphQL and REST that we typically use for HTTP use JSON, and JSON basically is a sort of space inefficient protocol because it's just everything text, and it needs to be parsed. It needs to be sort of the same way that if you as a human write JSON, you have the curly braces and you have the quotes and then you have the colon, and then you know, okay, this is the key value mapping. In the same way, the server and the client, for that matter, have to parse that, and that simply costs time. And it's not a massive overhead, but in a benchmark scenario where you don't have a lot of time, like even that can show up. What was important for us was to like not add new overhead for the user, like cognitive overhead. We're reducing computational overhead, but don't want to add a usage overhead. So you probably won't notice. You will still be able to use GraphQL, especially for sort of just learning the Weaviate API, just discovering it, playing around with it. The GraphQL console is an amazing tool. But at the same time, if you run your use case in production and you run it through the language interface that is our clients anyway, you might not need GraphQL anymore. So it's kind of a more options.
Yeah, super cool. So stepping into the ANN benchmarks a little bit, I remember you'd published that amazing ANN benchmarks collection, and we also had a podcast on that. I think it's like number 7, earlier podcast, and I think we're on like 47 or something. But
Wow.
so I remember so like the hyperparameters of the effective EF construction, max connections. So are all those fixed, and then each of these ANN providers all have to adhere to the same hyperparameters and the same machine? Is that sort of like a fixed hyperparameter of the HNSW kind of?
No, actually. So the machine is fixed, yes. And not even just the machine. There's actually a. So I said that the ANN benchmarks were single threaded before. It's actually not entirely true. They're limited to one CPU, which basically is not the same as single threaded. You can run multiple threads with that CPU, but there's no benefit because you can't ever exceed more than one CPU. So that is one restriction. One restriction is the build time. So I think if it times out after, I think 2 hours is the limit or so. So you can't run anything that takes more than 2 hours. But other than that, it's completely free. So you can set your own parameters. I think all the HNSW based implementations do have the same parameter set. So it's basically a grid search over all parameters. So you have EF constructions from very low to very high. You have EF from very low to very high, and same for max connections. And since the HNSW algorithm sort of works the same, I guess in a sense you're just comparing the implementations, and that also means that the parameters typically perform the same. So maybe in absolute terms, like one solution would be slower than another, but still for both solutions, like setting 8 connections would probably have the same effect on both solutions as opposed to setting like 64 connections. And then in ANN benchmarks, it's not limited to HNSW based algorithms. So for those, so for example, PG Vector is in there, the new Postgres plugin, which I think it's IWF based or something, or IWF PQ based. So it has completely different parameters. But that's the nice thing about ANN algorithms. You can compare them still, and sort of, yeah, you're kind of free to use all your parameters to get the best out of all parameters, under the restriction that you still need to be able to build it within 2 hours on a single CPU.
Hmm. So what scale is the test? Is it like the SIFT 1 million vectors, or like?
Yeah, we have SIFT 1M in there. I think we have, I forget the name, but I think it's like Deep 1B, which is not a billion. That would be a bit large, but I think it's 10 million or so. So they're definitely smaller and larger, but I think they're all within to 1 to 10 million.
Do you think maybe that's something that the benchmarks like should aspire to? Or yeah, just like the continued scale. Anyway, yeah. So the whole topic is so interesting. So maybe pivoting topics a bit, we also have in our release the Generative Cohere module, and So I'm really excited to talk about this because this is actually the first module I've ever worked on at Weaviate, and I mean it was pretty easy to the infrastructure that's been in place to extend these modules with new models or new external model providers. So OpenAI, Cohere, when the Anthropic Cloud model comes in, the Hugging Face transformers, GPT for all, the Llama CP, like all these large language model providers can be integrated so easily into Weaviate, and so I wanted to maybe ask you, Etienne, about your latest thinking on the large language model stuff and that kind of the trends in all these new models that are coming out.
Yeah, cool. So first of all, I'm really happy to hear that this was easy to do, because this is kind of the point of the module system. Like, there are so many sort of complex tasks within the database, both on the vector indexing side, but also on the just sort of old school database indexing side. So having that sort of almost sandbox scope of the module where it's very easy to integrate something new, that's
Mm-hmm.
always awesome. And or always awesome to hear that it actually works like this as it is intended. Which serves as a nice segue into everything that's happening right now, because we're really in this sort of crazy mode of something new popping up and breaking GitHub star records within a couple of days or something. It has more than everything out there, and I love that we're able to integrate them. I was about to say React, but I think React is not the right word. I think we're able to integrate them very quickly as they pop up. Because it's not, React would imply that we somehow like have to chase them, but that's not the case. It's just enabling users. There's something new comes up, be it a new model, a new integration, something that provides value in this AI space. And if it provides value, then there's a good chance that it can also provide value to Weaviate users. And I think being able to quickly adapt there and quickly integrate those is super valuable for our users. And similarly, having Weaviate basically as the stable API for them, I think is also super cool, because if you manually, let's say you're using generative OpenAI, so the completion endpoints from OpenAI, and now you want to maybe test that against the Cohere endpoint, and just want to see like, okay, what performs better for my specific workload. If you were to integrate with those two providers separately, you would probably have to adjust some code, because you wrote something that was meant to contact the OpenAI API, and now the Cohere API. I haven't looked at them, but I'd be surprised if they were identical. It probably is some difference. But if you use Weaviate with all of that, the Weaviate API is the same. All you have to change is the model, or change some string somewhere in the model that's essentially just configuration. And that goes for way more of these things. Like, this is just one example, you could argue like, yeah, okay, changing one of those requests is easy. But now if you combine that maybe with sort of the generative search, which typically is the retrieval step, and then the generative part, what if you want to change something on the retrieval side? You could have text-to-vec OpenAI, text-to-vec Cohere, text-to-vec transformers, contextionary, text-to-vec Hugging Face for any Hugging Face model. Probably new ones that have been released during the recording of this podcast. So
Yeah.
you can combine all of these 5 or however many it was. You can combine them in a hybrid search with BM25. So now we have this like large matrix of different options. And you can do this within Weaviate by simply changing configurations. So I think that's a nice additional value of having that collection of different model providers within Weaviate.
Yeah, I think that like that kind of like model inference orchestration of Weaviate is so fascinating to me. Like, whether you want to manage this on the database side or on the client side, and I think by doing it in the database, you just have kind of one thing with all this infrastructure, and yeah, the whole thing is so exciting. The kind of the one paper I really like that came out recently is Hugging GPT, where it's kind of about the large language model is like the task decomposer that routes it to the models with descriptions of the models. And I mean, the future of, like, we originally talked about this pipe API, which is kind of like a DAG of computation flow, like retrieve, rank, read. But now we're seeing such a dynamic kind of chaining of the things you can do with search interfaces, and it's so interesting. So the next topic is another innovation in search that I think is extremely exciting, so much potential with this idea, which is groupBy arbitrary property. And yeah, can you explain how, maybe with the document passage example, I think would be the best, like.
Yeah. This feature, this was basically a request from one of our commercial users. But when they requested it, we kind of almost expect this already, because it's just something that is an ever sort of growing problem that we now have a solution for. So the idea is, if you have your document split into some kind, oh sorry, not your document, your entire content split into some kind of hierarchy. Um, Typically you're either forced to give up the hierarchy, or you have to do some kind of workarounds. So what I mean is, for example, let's say you have documents and you have passages, and a document is sort of a grouping of a number of passages. If this is a very small grouping, you could, for example, do the ref to vec. So you could have them as two Weaviate classes, you can do the ref to vec, and then ref to vec gets the mean embedding of those passages. The problem with this is, as the number of passages per document grows, it gets harder and harder to represent so much information, because in ref2vec, essentially all gets combined into a single vector, and there's only so much information that a single vector can hold. So if you try to combine 1,000 passages, and these all have maybe diverse topics, so let's say it's maybe not document passages, maybe book and chapter or book and passage, then it's very, very hard to keep that meaning. So what users typically do is they would want to search by the sort of smallest unit, which in this case would be the passage. But then the problem is, well, how do I get back to my association of the document? Like, now I'm searching for passages. Maybe the top 10 passages are all of the same document. Maybe in the top 10 passages, it's 10 different documents. And what our users were missing is basically a simple way to sort of keep that kind of association and make that part of the ranking, basically. And with the groupBy feature, and it's a group by any arbitrary prop, but I think it's most interesting for this particular example to group by the reference prop that would be the association from passage to document. It now allows you to have basically the first hit comes in, and let's say it's off document 1. Then you can group all the passages that match that same document in one group, and then you can either sort of group this by what is the highest similarity per group, or you could take the mean similarity per group, or something. There's like more options. But basically, if you want to display, like if you want to search through passages, but to your users want to display documents, you can do this now, because by finding the one passage that fits the best, you still get the relatest passages, basically the most related passages in that same document that you can represent to your users. So it gives you like a nice way to display that as like almost like a tree kind of way, or various other ways. I think gives you more options to show that to your users.
Yeah, that's amazing. I mean, firstly, quick shout out. I was just at the Haystack Search and Relevancy conference, and Open Source Connections. I know they would love this topic. Yeah, so like with the ref to vec, you try to aggregate all the passages, and averaging is maybe too much of a compression. I used to think that maybe a graph neural network could aggregate those vectors, or maybe cluster some ideas like this. It also kind of reminds me of like multi-vector representation, where you have document and then passage, that kind of thing, maybe like title, passage, and so on, author. But yeah, that's I like the analogy of the podcasts, like taking these podcasts and then putting the transcriptions in, and you have all the chunks, and you have the similarity of the chunks that you aggregate. It's such an interesting innovation in search, and I like to call this like top level indexes. And yeah, I'm so excited to see how this evolves. So now transitioning into some new data. Oh yeah, unless you want to stay on that.
No, just I love your example about the podcast. And I just had to think, because we opened with the topic of benchmarks, and we also have a dedicated episode on benchmarks. So I think that would be a great example, because now it gives you the ability, like, do you want maybe that snippet from today's podcast, which is very relevant to benchmarks, but the podcast is not about benchmarks? Or do you want more the mean similarity, where you have a dedicated episode about benchmarks, where maybe no snippet fits as good as today's snippet, but overall you have the podcast that fits the topic better? And I think this is something that you can very nicely represent with the new grouping feature.
Yeah, amazing. That's a perfect example. Yeah, because the one passage matches it enormously, but then the whole collection, yeah, awesome stuff. So okay, so coming into the database stuff, and I think this is so interesting how so now you have a tunable option between whether you want to use the bitmap index, which I assume to be like a super fast inverted index because of how the underlying data structure is implemented, and then you also have the BM25 score index. So what goes into kind of this tunable indexing?
Yeah, so in the past, we kind of made an assumption that if it's text, you would always want to do a full text search. And that just, I mean, that may be true in some cases, but it wasn't granular enough. Because exactly as you say, we've introduced in the previous release, we've introduced those bitmap filters and everything. So we had it for everything except text props for this particular reason. And everything else is super fast now, but text still kind of like was sort of still the old implementation, because text was built in a way to be indexed for BM25, which is sort of, without going into too much detail, but it's very different because you need a lot more information. So for BM25, every hit and every association needs to be scored, so you need to know the frequencies and all these kind of additional things that you don't need to know for pure filtering. But now, if your use case is to simply filter and nothing else on text, on something that happens to be text, yeah, right now you get options. You can either index it only for filters, then it's fast, it's the BM25 index. You can only index it for search, then you can have, then it's basically the same behavior that you had before. So filters, if it's not specifically filter indexed, it can still fall back to the old index, to the searchable index. But if it has both, then it just takes the best at each time. And it's fully in your control. It's fully backward compatible. So by default, we build both indexes, but you can turn them off and then simply tune it. So if you said, like, okay, I know I'm only going to need, so for example, if the field is like a user group that you need for permissions checking or something, you're never going to run a BM25 search over that. You know it'll only be there for filtering. So just turn the searchable index off, keep the filterable index, and then you get fast filters using bitmaps under the hood for string properties as well.
It also makes me think about, like, you could probably represent categorical variables that way. Like if you have
Exactly.
that's super cool. So kind of related.
Yeah, just because it's a string doesn't necessarily mean it's full text. So that was kind of the assumption that we made before, but it simply doesn't hold true.
Yeah, super cool. And you can use those with the where filters. Yeah, amazing stuff. So then so now there's more tokenization options as well. Yes, could you maybe take me through the thinking around the tokenization?
Yeah. So mentioned string and text before, and I think this has been a big source of confusion for some users, because some users just assume that because it's string, it would use a specific kind of tokenization. Some users didn't even know that there was a split between string and text, so they used string for something that should have been text, or used text for something that should have been string. And as I'm saying this, well, what should have been a string, what should have been a text, like that's just not clear. That's very hard to explain, and that's why we've simplified this, and again, all in a non-breaking way. So right now there's only going to be text. String basically disappears, nothing breaks for you. You can still, in your APIs or in your schemas, you can still set string and it'll be automatically converted to text. And to keep that kind of difference that we had before, there are now more tokenization options. So you can tokenize, if you want, by the hold field, which is something, by the way, that a lot of people assumed that string would do, but it would only do that if you set the tokenization to field. So right now, that's simply an option. You can tokenize by word, which basically means Weaviate will split on the spaces, but will keep the individual things you can or will sort of keep the alphanumeric contents of the words, but it will remove special characters. You can also split just by white space, which is sort of, again, splitting at the word boundary, but not removing those special characters. So for example, if it's like a product description that has a special sign in it or something, and you want to keep that because it's relevant, then you can. So again, more control and simpler API at the same time.
Yeah, super cool. And so keeping on the APIs, so I've started diving into TypeScript and learning a little bit more about that. I've seen more of the consistency level, and so the newest thing, tunable consistency for vector search, and the GET request, and all that. Yeah, can you tell the whole? So replication is something that you can. So I hope I'm getting this correctly, and Etienne will correct me in a second if I'm wrong. But replication is like how you're replicating your data across nodes in a cluster. So how does this work with each query? You can tune this.
Yeah. So there's two sides basically for tuning. One is how do you write your data and how do you reach your data, and they somehow depend on one another. Because for example, if you make sure that during writing every node already has the same copy, it doesn't matter what you do at reading, because if you just read it from one node or if you read it from multiple nodes, you already made sure that they're in sync during writing. However, that has a large cost, because now for every write, all the nodes have to basically agree on it. All the nodes have to be alive. So with tunable consistency, the idea is to make some trade-offs. Basically, you could say I'm only writing maybe with a majority of nodes, and I'm also only reading with the majority of nodes, and then okay, we still got some consistency guarantees, basically, because if both writes and reads happened with a majority of nodes, then it should still be consistent. Or you could say it's actually not super critical that my data is always up to date. Maybe you want to accept that it's sometimes a bit eventually consistent, so it could temporarily be out of date and hasn't been repaired yet, and that may be fine, because maybe something that you're updating it's not bank account details or something, or bank transactions, but rather product search, where it's not a big issue if something is slightly outdated, or maybe you can catch it on the application side if it's outdated. And for GraphQL searches, basically that was the last point that we had, where we didn't have tunable consistency yet. And for those queries, you can now set it there as well.
Mm-hmm. Amazing. So everyone, we are a little time constrained, so we're cutting it a little short. But as always, the incredible DevRel team. There's this release blog post with all these releases. If you want to consult more details, Eddie and I are available on Slack and more than happy to answer any of your questions. So gRPC, Generative Cohere, group by arbitrary property, bitmap indexing, more fine-grained control over that with the text search, deprecating string with more tokenization, and the tunable consistency and some patch releases. So yeah. Thank you so much, everyone.
Awesome.